Okay, guys, as I told you before that, the deadlock avoidance method will follow some algorithms. And those algorithms will always examine the system or check the system or ensure that the system should remain in the safe state and not go to the unsafe state. So is there a single algorithm or multiple types of algorithm? So dear students, as we know that we have two types of resources, single instance resource and multiple instance resource. Single instance resource mean what? Who can tell me? Ahmed Faisal. Single instance resource mean what? Raise your hand if anyone have or know the answer. Yes, Ahmed Shakur. Ahmed Shakur.
Salam alaikum. Can you hear me, sir?
Yes, I can hear you. What is single instance resource?
Sir, can you hear me?
Yes.
Single resources mean dedicate, sir.
Dedicated resources.
Dedicate, sir, or no shareable?
Not shareable.
Yes, sir.
Yeah, Muhammad Idris Qadri, there will be single instance. And single instance mean a resource which will be not able to become available for more than one process. Okay. Ahmed Faisal, what is multi-instance resource? Okay, Faisal, you are silent, so it's unfair. Students like you remain silent, okay? Yeah, multiple instance resource means shareable resources, okay? Okay, guys. So if your system is consist of shareable resource, then they will follow banker algorithm. If it is consist of single instance, then they will follow resource allocation algorithm, okay? This is very much important thing, dear students, that in the avoidance algorithms, if your system is consist of single instance, so for single instance, what will be used? Resource allocation graph. And for multiple instance source, what will be used? Banker algorithm, okay? Okay. The resource allocation graph is same as we had discussed at the previous lecture. That was a resource allocation graph. And if you remember, I told you that the resource allocation graph will be consist of multiple vertices, and where the vertices are consist of what? P and R, where P is a resource. Okay, edges and some vertices, where the vertices was what? R and P, and the edges were request edge and assign edge, okay? So the concept is the same, but we have just only one new edge, and that edge is called claim edge. That edge is called what? Claim edge. So dear students, in this resource allocation graph, we have what? A new edge by the name of claim edge. And let's try to understand how this claim edge will be used. For example, I have R1, I have R2, both are single instance resources. I have two processes, P1 and P2. Okay. So P1 arrived R1 and R2. Okay. So P1 arrived. The P1 must claim that I will need 1 instead of R1. Remember, they will claim, they will not request to the system. As I told you before, that every process must declare their maximum need before their execution. So they will claim, the system will see R1 is free. Yes, R1 is free. Then the system will let the P1 to request this resource. Then the P1 will resource R1. So of course it is free. So it means it will be available to P1. The same thing will be repeated here. P2 will claim to the system that I need R2. If R2 is free, then the system will let the P2 to make a request. And the request age will convert it to what? To assign age, because the R2 was free. Clear? Very good. Now, the P2 is saying that the R2 is not sufficient for me. I will use R1 too. So let me make a request. But when they will make a request, then the hold and wait situation will become true, and they will cause a deadlock. So the banker algorithm, sorry, this resource allocation algorithm is trying to avoid this. So that's why before making request, they will age. They will claim, they will generate a claim age. Claim age means they will claim to the OS. The OS will say, no, R1 is already occupied by P1, so don't make a request. Don't make a request. So it means here, there is no request age. Let me draw here. There is no request age. When there is no request age, there is no possibility of deadlock. And the same here, when the P1 want to use R2, so before making a request, he must claim. If it is free, then he will make a request. But you can see here, right now, the R2 is not free. So that's why the P1 cannot make a request. So when there is no request, it means there is no hold and wait. There is no circular wait. So resources are allocated fairly and there is no deadlock. There is no deadlock. If you guys understand the previous lecture, lecture content specifically circular wait and hold and wait, then you guys can easily understand this. Otherwise, I'm sure you guys are confused, okay? Because some students will think that, okay, if no request, how no possibility of deadlock. And we had discussion about this, that whenever a process make a request, it means he is waiting. And when he don't have a request, it means he's not waiting. When he's not waiting, it means no possibility of deadlock. And who is not letting them to make a request? The OS, because the OS have a prior database of the resources. They know that how much resources are available. And he also declared the principle that whenever a process is going to be executed, he must declare their maximum need. And then I will see that if the resources are available, so I will let him to make a request or execute. Otherwise, I will not let him to execute or to make a request. Because why? Because to avoid the deadlock, to avoid the deadlock. So dear students, this was resource allocation graph to manage the single instance resources. So right now, there is no deadlock. Okay, if Idris Qadri say that, okay, when the R2 is not sufficient for P2, then of course the P2 have to wait for the R1. So dear, but see, you can see the right now, the P2 is already holding R2. So it is possible that the P1 will release R1 and it will be allocated to P2. Because it's not a heavy process. If it is a heavy process, then the system will say that to P1 or to P1 that you should release the existing resources. You should leave the existing resource if it is not sufficient for you. Okay. Yeah, there is the system is on unsafe state. Because of what? Because of this request age. Because of this request age, okay? Because P2 is requesting R1. There's no claim. So there's request age, and because of this, is a hold and wait situation, and this hold and wait situation can cause this, can lead the system to be in the unsafe state. In unsafe state means possibility of deadlock. And the resource allocation graph algorithm is already stated that there should be no request age. There should be what? Claim age. When the resources are free, then they can make a request. Otherwise, they cannot make a request. Who cannot make a request? Process. Not you guys, okay? So dear students, this was the resource allocation graph. And as we understand, suppose the process PI requests a resource RJ. The process PI mean a running process. A request resource mean a RJ. A RJ resource mean a resource which is already occupied by another process. The request can be granted only if converting the request age to an assignment age. It means if it is possible for the system to allocate the resource, then the system will let the process to make a request, and then the request age will be converted to the assignment age. Because such thing will not cause a cycle in the resource allocation graph. If no cycle, no deadlock.